So if we look at this, we can say, ooh, well, we have two functions now that I'm trying to multiply, but we have some domains here, right? So if we look at this, the domain is, this is going to be all numbers. Remember, we have to take whatever's under our radical, greater than or equal to 0. So we could say x has to be greater than or equal to 4. So if I was going to write that domain, I'd say 4 to infinity. Then I look at this domain, I say, all right, whatever number under my radical, or under my, fraction, is going to make it 0 is not in the domain. So I add 1, divide by 1, we can say x equals negative 1. So when x equals negative 1, that's not in my domain. So this range is negative infinity to negative 1 union negative 1 to infinity, something that we already discussed in domains of functions. Questions? Yeah? Good? OK. So these are our two domain restrictions. Now, it's kind of helpful, though. Does this domain actually affect this domain at all? No, because this one's saying all numbers greater than 4, right? So when I multiply them, add them, subtract them, it doesn't really matter. The domains are going to stay the same. So if we're multiplying this, so if I'm doing g of j of x, again, guys, that just means g of x times j of x. Well, how do you multiply square root of x minus 4 times 1 over negative x minus 1? Well, again, just think of that as a fraction and just multiply straight across. So therefore, we have square root of x minus 4, because that times 1, divided by negative x minus 1. Now, if I was to give you guys this on a test, which we did look at a test, you might be, oh, crap, this looks so confusing, and I can't remember how to do this. But again, if you just break it up into each function, you see that, oh, this is for values greater than 4, and this is x cannot equal negative 1. Well, this doesn't really matter, because if negative 1 can't even be under the radical. So therefore, this is my domain that is going to remain. So I only need to write one domain here, which is 4 to infinity. So that is the domain of the function. So you can identify the individual domains, but when you add and subtract them or divide, like, the domains don't change anything. Or add, subtract, and multiply. The domains aren't going to change.